Alright everyone, welcome back to Cody's Lab. This here is a piece of tempered glass which has been heat treated to induce stresses that allow it to withstand forces that would break normal glass, such as a hammer. It took that without any trouble. As tough as this material is, it does have a weakness. If you scratch through the outer layers and expose the inner core of the glass, which is under stress, the glass will rip itself apart. Fortunately, glass is pretty hard. It's harder than steel, so I can't scratch it with a hammer. But if I have something harder, such as corundum, which you find in things like spark plugs, or say diamond, which you find in this diamond glass cutting bit, as long as I keep it wet, I can grind through a piece of untempered glass using this bit without any trouble at all. But if I try to do the same thing on a piece of tempered glass, it doesn't work. You cannot cut through tempered glass without causing it to explode. What I want to know is, could you dissolve a hole in it? I got 2 soda caps, cut a hole in the bottom of one of them, and I'm going to glue them to the glass using some silicone, which I have previously tested to determine that it is resistant to HF. Okay, as you can see, we're in the fume hood. I've put down some lime, and here's the glass with the caps glued on. This way I can put the acid in there, and when it dissolves through the glass, it'll be caught in this one and it can dissolve from the other side. That way I can end up with a nice round hole. At least that's the idea. Let's just set this just like that. So, I guess it's time for the acid. What I'm going to do is add it in just little portions, because the glass will form insolubles, which makes the dissolution happen more and more slowly. So what I'm going to do is periodically remove the acid, clean off the glass, and start over. There, I guess. Put something over top of it so it doesn't fume, and close down the shield. I'll just leave it there and we'll come check on it in a day or two. Okay, it's been another day. Let's see what we got here. Looks like it's developed that crust again. Let's take the acid off and neutralize it. Okay. I'm going to take this, go clean it up. We'll see how it looks. So here we are. I've cleaned off all the silicone. Now you can see the progress after dissolving for about 1 week. Let's say I'm right about halfway through the glass. So this is making me think that I might actually be able to get through it using the acid. I'm going to flip it around, and I'm going to dissolve from the other side now. Hopefully that'll make it a little bit more likely that it'll actually get through. Okay. Put a little bit more acid in. Start dissolving it from the other side. Well, it popped. I expected this to happen, but last I checked on it, it was 3/4 of the way through. I was getting really excited that maybe this was a method to actually get through the glass. But nope. As soon as you expose that core that's under high pressure, the glass is just going to explode. Let's look at this. It's all here. Okay, so I've cleaned off all the acid, and I've removed this cap here while leaving some of the silicone behind in order to kind of stick the glass together so we can see what it originally looked like. You can see, there it is. It definitely thinned it substantially. Let's take these calipers here and actually measure that. It's about 1.2 millimeters. And the original thickness of the glass before dissolving, about 4.76. Here's a little closer look. You can see that white crusty material that forms. I think this is mostly calcium fluoride, because this is soda lime glass. And calcium's fairly insoluble in hydrofluoric acid. Yeah, I was hoping that this would be a method to get through the glass, but even though I was dissolving it slowly over a period of weeks, at some point it just reached a tipping point and the glass tore itself apart. Hope you enjoyed. I'll see you next time.